I'm going to go over all of my kind of latest prototypes, not all of them, but you know, the most relevant ones for now. And I'm going to sprinkle in how I think of frames when I design them and my design language in the middle of all this to kind of help the newcomers that haven't seen all my old videos. So I'm going to start off with the floss frame. This is my floss frame. This is probably my most, not probably, most definitely my most popular design at this point. And I don't even know how it's so popular, but I guess people really wanted a nice, good, light, not the weakest, but good frame to fly. So the biggest advantages and features of this frame is that the arms are skinny, hence the name Floss. Also, I'm a dentist, and I want everybody to floss, so please floss. Again, hence the name Floss. And having skinny arms has a couple of advantages. Number one, it makes it lighter, obviously. And number two, it reduces the drag tremendously. And I'm not talking about drag like flying forward drag. I mean drag like the actual thrust coming off the prop disc. So it doesn't disturb the thrust as much as having a wider arm. Previously, I had designed the Evo frame, and the Evo frame is good, it's great, but it does have wider arms. In addition to the wide arms, it's got a bunch of meat in the middle here and a bunch of meat around the motor here, which it does make a significant difference. I have taken this frame to a aerodynamics engineer at Caltech. He has done some drag analysis on the arms, and he initially said that I should be running not skinnier arms, maybe just more aerodynamic arms, and my argument was that they're already only 8 millimeters wide. If you make them 4 millimeters wide, like he recommended, I wouldn't be gaining much aerodynamic advantage. There's diminishing returns, and he came back an hour later after running a bunch of simulations and said the same thing, that you're right, you're not going to get any real aerodynamic advantage, you can't even calculate it. The other thing about this frame is that it's an evolving frame. I'm going to go over how it's designed and why it works the way it does really quick, and then I'll tell you how it's evolving. So if you look at the frame, the most unique thing about this frame, which was just done on a whim, I didn't really expect it to work well, was that I refused to make a sandwich plate. I had a sandwich plate version of this frame, and I just did this just as a whim, and like I really hate the idea of the sandwich because number one, it's a pain to build because you got to sandwich those plates, get the arms in the middle, and then if you break an arm, you got to manage the sandwich. And if you have different screws for the stack, then you got to make extra holes in the bottom of the sandwich to fit the screw holes up through it, and then you get longer screws, so you get extra weight that you don't want. Whatever. The sandwich is just not really the most optimal frame design. So I just went with a single 3 millimeter design. I went with 3 millimeters because 3 millimeter. There have been 3 millimeter unibody frames in the past, and they've done decently, not great, but decently. They're not the weakest frame, and for our little racing group here, people actually like the 3 millimeter unibody frames. They don't like the 4 millimeter because it's much lighter. So I went with the 3 millimeter unibody main plate because it is 3 millimeters and it's light. And you'll also notice that the main plate is cut in this angulation, and the reason I've cut it in this angulation is because the fibers, as you see, are running straight along the arms, and I wanted the frame to be strong in this area, which is where the arms connect. I want it to be as strong as possible. And if you actually take this frame in your hand and you flex it by the arms, you will notice that it really has very, very little flex. The flex is not even coming from the arms. Any flex that it does have is coming from right here, which is arguably the weakest point of the frame, right over here. And that I've seen it break a handful of times, and I'll talk about that in a minute. So when the frame does break, I have designed it to break primarily either right here in the arm area over here, or right here where the connection to the motor pad is. I have opted not to make this connection wider because I want this area to break in a crash because it's the easiest area to repair, and it takes the biggest impact, and it just saves your motor and it saves the rest of the frame. So it's a good place for the motor to break on this little edge, this line here. It is, and also if I had made it wider, it would obstruct more airflow, so it's just generally not a good idea. You'll notice that the arms have only 2 screw bolts, and they're relatively close together. They're almost physics-defyingly close together, and the issue with just having the arms bolted to the frame is that over time, over a bunch of crashes, these bolts lose their tension, and the arms have a little bit of wiggle in it. The very first prototype I made, the arms actually wiggled too much, and the props would touch in the rear, just a little bit, front and rear, just a little bit if they were totally closed. My solution to this was to just make the arms a little bit wider, not necessarily wider. I just changed the angulation so that even at maximum flexure close, they don't really touch. There's one guy on another video, which I don't even remember which one it was. I don't remember his name at all. But he has been arguing with me that the movement of the arms causes significant flight performance differences, and it causes vibrations to get to your flight controller. And he's an engineer and works with transportation and people, and he's so much better than everybody else. And he is really arguing with me that I need to improve this right now, or else, I don't know, something's going to happen, and something's really bad, and I don't know what I'm doing, and everything is wrong. And I eventually just stopped responding to him, but I'm sure he'll see this video, but my response to him would be, I know I am not an aerodynamic or transportation engineer. I am a dentist, but I have probably been doing this a hell of a lot longer than you, and I'm sorry, but it does not make a difference. This minor arm movement in the air is not going to make a difference to your flight performance in any way, shape, or form, and it will not make a difference to your durability. And in fact, even the Alien frame, which is legendary for its durability and construction and how firm and tight it is, has 3 holes per arm, and even that frame gets loose over time, and people swap out the arms because they don't like how it's nice and loose, how it's all loose and just a little bit of movement to it. These arms are perfectly fine with a little bit of movement. If they do gain more movement, just swap out the arm, you get a new piece of carbon, and the arms are $2 a piece, no big deal. Also, another thing about this, there's a lot more I can discuss about this frame, but another thing about the top plate is actually a structural function. It does have structural function. It is not just a skinny top plate. The top plate is designed to strengthen the front arms, and if you do flex it, you only really get flexure from this point, and in a bad crash, really the only place you can break the main plate is probably this one point, because it does not have that structural top plate. This entire frame is a compromise. There's nothing on this frame that's, you know, really solid and good. Everything about it is a huge compromise. Top plate is skinny. It definitely does give you some protection. It is not the weakest frame in any sense at all, but it is skinny, and it has 3 standoffs because it's got to be light. This frame currently weighs about 59 grams, 60 grams, no, never mind, it doesn't even weigh 60 grams. It's like 55 grams in its current state like this, 55, 56 grams, I don't know, whatever it is. However you build it, it's somewhere between 55 and 60 grams. It's a pretty good weight. The original frame that I designed was 47 grams. And over the different batches that we've been getting, I had that initial prototype batch, and we went forward with everything from there, and I basically just improved small portions of the whole design. The arms are now 8.2 millimeters wide. I did make a set of much wider arms, but I opted not to release them, because with wider arms and much stronger arms, you then have the issue of potentially breaking the main plate, which is not a good thing. The areas that have changed the most is that the main plate has changed, not a lot, but a little bit. Basically, this area has become a little bit wider to withstand a little bit more forces, and the arm has gained a little bit of meat around the connection portion and a slight amount of meat around the motor pad connector, and the motor pad base is a little bit wider, and I think I even extended the motor bumpers just a tad. Alright, so now let's move to all the other ones. I'm not going to talk as detailed about the other ones. Oh yeah, one other thing. If you don't know about stretch Stretch X frames, where basically the front to back dimension is longer than the side to side dimension, are hugely beneficial because you actually have prop wash coming off the front disc and impacting the performance of the rear discs from being able to function. So when you stretch the disc out, stretch the distance out between the props, you get more clean air with less tilt. The end result is that you're able to go faster with less tilt, and you have more control, and it really carves the corners with less effort. So I prefer Stretch X builds, especially on a bottom mount battery setup. When you have a top mount battery, it's not as important because of balance, weird balance things, but it still makes a pretty good effect. Alright, so from there, that's the 5-inch version. There's a 4-inch version. Oh, is this a 4-inch version? Yeah, this is the 4-inch version. Originally, the arms had these little slots, had notches in them. They weren't just like whole circles, so that I could remove the arm with just one screw. But I quickly got rid of that because a couple people broke the arm right there in that center, so I made the whole complete. So now I got to remove 2 screws. Anyways, the 4-inch version is really nice, really strong. I don't recommend 4-inch because it's just not as fun as 5-inch. I don't really recommend anything less than 4-inch. That being said, I am designing 3-inch. This is the 3-inch Floss. This is the 3-inch Floss, and originally I designed it with the separate arms, with you know, 2 sets of screws per arm. This is unfortunately heavy. It's about 39 grams. And then I redesigned it with the front arms being connected. I don't like connecting the arms, but because the arms are so skinny and small and just tiny, they're really easy to cut. They're very cheap to cut, and they're still going to be cheap to sell. That's a big factor of why I haven't connected the arms on this, because once I connect these arms, then it becomes an Evo. And you also notice that the arms are very short because I've extended the main plate kind of far so that there's less torque on. I can talk about this frame forever. And there's a lot into that design. But anyways, here is the 3-inch version. This is the almost final design. This is not the final design. I've noticed that recently the 3-inch is designed only for 20 by 20 mounting platforms. It is not designed for taking 30.5 millimeter mounts. And still, I still prefer, even on a 3-inch, separate arms, separate everything, not a unibody build. What that allows me to do is I can run skinnier arms and I don't have to worry about it breaking, because if you do break an arm, it's really easy to just swap the arms out. They're really cheap to replace, really easy. The weight is actually 1 gram less than my Hyper Baby design, my previous design, so it's still a very good weight. And you have the modular design, and it's a skinnier profile, so you have less drag profile. This is 3 millimeter. All of it is 3 millimeter. It is way too strong as it is, but it's only 30 grams or 29 grams, and I think that's a pretty good weight. The final version is going to be a little bit longer, and it's going to have 2 millimeter hole space, or just M2 mounting holes, as well as M3 mounting holes for the various different 20 by 20 mounting solutions for your flight controller and the 4-in-1 that you're probably going to use on this frame, because building a 3-inch without a 4-in-1 is pretty much ridiculous to me at this point. This was my previous top mount acrobatic frame, which I loved until I started having issues with it. You'll notice here that I'm using the wider arms, and the reason I'm using that is because it's an acro frame. I am going to crash into things. I am going to bump into things. I do not want to deal with broken arms at all. I will tolerate the extra weight because it's an acro frame, and you know, I'm not going for maximum punch, and it's not really going to make a difference to my flying style. This is the top plate. You will notice that it has 5 standoffs, which is not the best, but decent for now. And you'll also notice that these holes over here are designed to put the battery sideways. And while that's a great concept and it works well, and Gapit has made that really popular, and X-Hover has actually made a frame that has that kind of mounting as well, but they abandoned it for a lot of the same reasons I abandoned it. It just looks weird, and there's always a risk of slicing the battery with your props if you bend the prop. I never actually sliced the battery, but it was always a concern for me, so I kind of abandoned it because it just looks ugly. It really just looks ugly. And also I was having small issues with the frame. The Floss frame will not support a 500 plus gram build. I do not recommend you build it at 500 plus grams. I know that there's a GoPro mount for it, and people that are running this frame with the GoPro mount need to understand that that frame is overloaded, and if you crash, it is going to break something. It's not weak. The frame is not weak. If you build it at under 500 grams all up weight, really 430, 450 grams is recommended. It will be very durable. It will not crash as easily as you think. You will be surprised at the durability of this frame. This frame, on the other hand, was designed for a 600 gram all-up weight, or around 600 grams, or not 600, 550, because it's supposed to still be lighter, 550 grams all-up weight. But the issue is that I constantly had, not constantly, a couple times I crashed and I broke the plate right here. So I made this plate really wide in this area, and I did not expect it to break like this. And I even cut the plates like I did cut the previous Floss frame, and it still broke, which is really upsetting and really concerning. I did cut 3 and a 3.5 millimeter versions of this plate, but then the frame just became like 75 grams, 80 grams, and look at all this hardware, so it just added up really quick. So I just abandoned this design because it looked ugly, and it was, you know, not really the easiest design to build, kind of cumbersome to use. Sideways battery was weird. It didn't meet, I loved flying it, the performance is excellent, but it just didn't meet my standards for usability and ease of just build and just maintenance. So I abandoned that. This is the 6-inch version, which I also built, and I was surprised. This is the first 6-inch that I flew in a long time. I was really surprised at the performance of it, so I did make another 6-inch version of my other frame, which is the most recent. But before I show you that, let's show you this. This is the top-mounted Floss frame. It is basically the same bottom. It's a little bit longer to accommodate a vertical top-mounted battery, not a sideways battery, because I don't like the sideways battery, even though the vertical just makes it annoying because it's going to be heavier. But anyways, so the main plate is about the same. Arms are all the same. It's all interchangeable. It's just a little bit longer. I am going to put a permanent VTX antenna hole on the main plate because I mean, I just like running a full VTX antenna, so I'm just going to put it on there. And if you don't like it, you can just chop it off. But the top plate will have holes in it for the antenna straps, and it'll be a little bit longer. I'm not 100% sure if we're going to release this frame yet because I'm still in testing it. But I can tell you that the battery on top for racing is far superior than the battery on the bottom. I know Brian Morris has not felt as big of an effect on race flight. That's very likely because they do have different PID settings and different filtering, so maybe they're better at managing the weird weight distribution on the frame. But for the most part, Betaflight, which is what I primarily fly, I feel a a very significant difference between top battery and bottom battery. And even the issue where if you do crash in a race, you will probably land on your top. I don't care because it feels so much better to fly, and if I crash, I'm probably out of the race anyways, so I'm not worried. I'll just deal with it, and probably in time there will be the turtle mode or various modes that flip you back over, and if they actually work, then no worries there anyways. I also don't like the upside down builds where you put all the electronics and everything underneath and the battery in the middle, because you still have to worry about the battery getting sliced because it's right between the blades. This way it's above the blade, so you have much less of a chance of slicing the battery or any wires. The upside down weird builds also have to be bigger to accommodate the battery in the center, so I don't like a big frame. I prefer a smaller frame, so I'm going to stick with this kind of a solution. The frame does weigh more. Unfortunately, it weighs about 70 grams. I think 69, 70, around. It'll probably be around 70, 71 grams, which is perfectly fine still for racing because I do like running heavier motors and heavier setup anyways, so it can accommodate the weight, no problem. Having the battery on top means that you're going to have much better balance. You're probably going to be able to fly faster anyways. It's going to feel much better. You're going to sacrifice a little bit of punch for the performance of handling, which I think is totally fine. The biggest difference between a top mount battery and a bottom mount battery that you'll feel in flight is that when you're coming around a turn, your bottom mount battery is really going to swing the quad around, and you have a hard time kind of just like managing the craft in just like a half angle. You're not really, doing a full turn. You're not really doing you're not flying straight. You're kind of just holding. You're just cruising. You're just carving that turn. Anyways, that's a top mount frame. Look for it. Maybe, I don't know when it'll come out. I'm still testing it. I don't have time to do this stuff all day, but I hope to make it a reality soon. Next is going to be my current favorite, and I'm going to clear everything out because I freaking love this thing. This thing is awesome. I truly underestimated how amazing just the basic Alien setup is. I've never had an Alien, and I have had Alien setups before, but I wasn't a good enough pilot to really understand and know what it meant and how to use it. And now I can feel a huge difference with this setup. First and foremost, with Acro, I do not recommend any motor smaller than a 2207 or a 2306. Yes, you can do whatever you want with anything smaller. This is my recommendation. You can use whatever recommendations from anybody else you like. I'm not telling you this is an absolute. It's just my recommendation. Bigger motors have much better control. They have better control because they have much more torque. And the torque is what gives you the control. That is how you live and breathe in acrobatics or racing or anything else really. Additionally, I've recently learned that I have always liked higher kV motors, and I think we have solved the reason why I like higher kV motors and why a lot of people like higher kV motors. It's because the higher kV motors draw more amps. They draw more power when they're doing any movement at all, and that equates to more torque. So while it's unfortunate that they draw more amps, you do get much more torque. Not much, I don't know how much more, and this is still just a guess, it's still just a theory, but it makes a lot of sense. The higher kV draws more amps, so it's able to execute movements and maneuvers much easier, so you just get that feeling boost when you're flying. I love these motors and I love these props. These props are the only props that will run so far in acrobatics. That will probably change in the near future, but I still prefer these props over any other prop for acrobatics. These are the Dahl 5x4x3 V2. I do not like the new HQ 4.3 prop, the 4.5x4.3x3 V1S. Just not good. I don't like it because the throttle feels mushy and it doesn't feel it doesn't feel predictable. I'd rather have a much more predictable prop. This is the best 5x4x3 I know of. This is my preferred prop. The Racecraft 5x4x3 is also excellent. This frame in general with the top mounted battery weighs about 600 grams. It has excellent performance for something that weighs 600 grams. It does not have the punch of the Floss at all, but that's really the only thing it's missing. Well, it's not quite as agile either. It can't really zip through like a slalom as quickly or as easily, or change the direction as easily, but it's really nice and smooth. And the reason why I love flying this frame and just traveling with it and moving with it is because it's so easy to maintain. Like, even when I crashed in my last video and I ripped the video wire, I did not have to take anything apart. The video wire is right there. Right there, right there. That's the video wire. I just soldered it right back on, and I was up again flying. It just didn't have my soldering iron at the time, so I couldn't solder it on at the site where I was flying. But whatever. I know it's a really messy build. This build has been through like 6 or 7 frames, so excuse me, please. Sorry. The frame is really easy to build, really easy to maintain. It's really strong. You saw those crashes that I went through. I've been through many more. It has very little flex. Actually, I don't know why it's clicking there. Let's see. Oh, no, it was just, oh, I have a screw loose. Oh, yeah. So this frame has the same issue as the Floss, where once you crash it a couple times, the screws get a little loose and the arms get a little movementy. In the final version, I'm going to try and key the arms together in the middle, as well as, use some accessory screws around it to grab hold of the arms and stabilize them. But for the most part, I'm going to make it such that the movement doesn't matter and the props will clear everything anyways all the time and nothing will touch regardless. I think it's about a 220... I think it's about a 228mm frame, which is a good size, and the biggest reason why I don't like putting the battery down between the blades is because it's going to require you to have a bigger frame. I do not like big frames. I don't like running a frame that's big enough to run 6-inch props and only putting 5-inch props on it. So I prefer a smaller frame. I cannot tell the difference between the battery hoisted that high up in the sky versus being on the main deck right next to the motors. It does not make any difference to my performance feel in any way. I can't tell the difference. So I don't even bother trying to drop the battery. It's not of any use to me. Having the battery underneath would make a huge difference, but having the battery on top, low versus high, I can't really feel the difference. This thing rolls pretty much right, the center of roll is like right around here. It's just above the prop disc, so that's good for me. I think it flies absolutely phenomenal. I think for beginners, for advanced acro pilots, I think this is a amazing frame. The total weight of the frame, the final frame will be about 94 grams, and that's going to be the 5.5-inch version. I think I'm only going to offer this frame in 5.5-inch because I truly believe 5.5 inch is the future. People will all eventually move to 5.5 inch. It is not much bigger. This one is about 220, actually I think it's 226 millimeters, and the 5.5 inch is going to be 237 or 238 millimeters. So it's just a little bit bigger. I mean, it is bigger, but it's just a little bit bigger, and you have the 5.5 inch prop, which makes it even a little bit bigger, but you're going to get so much more just control and so much more ability to move, and you're going to get so much more efficiency after that. I'm going to have another video about the next jump in FPV and these crafts, which I'm predicting, and I'm predicting it's going to happen very soon as well, because I'm going to make it happen very soon. I do have a 5.5 inch prop that I am designing on the way. I know that there's about 6 other 5.5 inch props that are coming out very soon, and here is one of those props. This is the new prop, it's not really that amazing of a design either, but it's a prop from Gemfan. This is a 5.5 inch, it looks like it's a 7-inch prop that's cut to a 5.5 inch bullnose, but Gemfan really knows how to make a prop, and they do it really well too. It's just that this is like an experimentation for them. They're just they sent me a bunch of these props to experiment with. They perform fantastic. This is the 5.5 inch version of that frame. Also the second version of the, what I'm calling the cow frame for now. The final version will have 2 strap holes right here to accommodate 2 straps so they don't move around at all. They're stationary right there. And it's pretty much, the rest is all the same. It has changed a little bit, and I've just tweaked some things kind of here and there. And the 5.5 inch arms and everything are going to be about 94 grams is going to be the weight of the frame, which is a pretty good weight to me, I think, for acrobatics. It's not going to be super light. I really wish that the all-up weight was more like 550 grams, because I prefer that for acrobatics. But at 600 grams or just under 600 grams with a fully built everything, all this stuff that you see on here, this with these motors, which are a little bit more heavy, it's like 615 grams. So it's very reasonable. I mean, the Chameleon and various other acrobatic frames are, a little bit above 600 grams. The Alien, Steele says that his Alien is 599 grams or something. I'm going to have to call BS on that, because the Alien weighs 50 grams more than this frame, and I'm using comparable components to him. I cannot see how he can get that frame down to 600 grams when it weighs 50 grams more. I think that his setups are primarily around 650 grams. I don't know, I'm probably wrong, but still, especially back in the day when he was running the TBS Cube, that thing's a tank as well. And on top of that, the PMP core, which is another like 10-15 grams unnecessarily loaded on top of the frame. So there's honestly, I don't know how it's possible to get that frame down to that weight with all the chunky build that he builds his frames with. But it's fine because, you know, he's comfortable with that frame, and that's how it performs well for him, and, you know, he's obviously doing great. So, you know, more power to him. This is the last thing I'm going to show. I have more, but I just don't have it with me. That's all I can think of at the time. I'm parched from talking so much. Oh yeah, I'll tell you a little bit more about props. So people talk about props and they talk about drift. And I think that people don't really know what drift is so much because they don't really compare them against other kinds of crafts that don't have any drift. The first thing people notice when they pick up a floss and start flying it is that when you pick up this frame and you start flying, it weighs about 150 grams less than your typical race build that anybody would typically build, 100 to 150 grams. And you'll notice that it's really, really, really point and shoot. You really literally just point it in a direction and punch it, and it goes exactly in that direction. When you make turns, the first couple times you make a turn, you actually take the turn a little too tight. At least that was my experience and many others that I've talked to. You take the turn a little bit too tight and you run into the flag or something because it's so point and shoot. It doesn't have a lot of drift. Drift comes from overloaded prop discs. So this is the disc loading theory. When you have overloaded prop discs, then you start drifting through the air because the prop doesn't have enough bite on the air to grip and pull you forward. So when you're coming around the turn, you kind of have to hook the turn and then flip back and go. Whereas these kinds of frames that are very light, you don't have to hook turns, you just turn. You just go, turn and go. It's much easier to fly and it's more reliable when you're flying on a track. It's easier to fly more consistently with a light setup. If you move to 6-inch with even a 600 gram build and put a 6-inch tri-blade on your build and you try to do a power loop, the first time I tried to do a power loop with a tri-blade and a 6-inch, I was shocked because I almost ran into the ground. Because when I do power loops, I'm often pulling up more and more and more. And it's kind of drifting as I'm turning and going up. Like it doesn't go like this. It like drifts as you go up. And so the first time I did a power loop with a 6-inch tri-blade, I did such a tight loop, I shocked myself and almost ran into the ground. And that is what having little or no drift means. You go around a turn or you try to do a power loop and it does exactly what you tell it to do. It does not drift. It does not require more throttle input. It just does it. That's what I'm after. With 5.5-inch blades, you get much, much, much closer to that no drift status. And it's much easier to build a frame that is a super light kind of flying frame. So for the disc loading theory, 250 grams for a 5-inch set of props is about the limit you want to go to. For 6-inch, that limit goes up to about 350 grams. Getting a 6-inch build, dry weight, that means no HD camera, no battery, down to 350 grams on a 6-inch is really, really, really easy. So why should we do that? Let's just go to 5.5 and actually match the prop loading theory, sort of, with the all-up weight or the dry weight that we can actually get on our builds. So 5.5-inch is really the sweet spot in the middle. 6-inch is annoying because it's a little bit too big and it becomes hard to make a prop durable. When you run into things, 6-inch just has too big of a torque lever and it just hits things and bends easier. 5-inch is going to be the fastest setup, but 5.5-inch is not going to be far behind, and 6-inch just starts slowing down a little bit more. When you get a 6-inch on 5S will be about as fast as a 5-inch on 4S. That has kind of been my experience that I've tried in the past. I don't know if it's still true right now. Last time I tried that was like a year ago. But that's been my conclusion. That's still my thought in my head. So 5.5-inch is going to be a little bit slower than 5-inch, but very, very little bit. And if you make the prop correctly, it should give you much more flight time, give you the punch that you want, give you less drift, and it's not much bigger. So I believe that everybody's going to be moving to 5.5-inch. And I already have 5.5-inch arms for the Floss frame, although I have not built it yet. GemFan has made me a set of custom motors to test my theories, as well as a set of custom ESCs and custom props. And I'm also working on another prop on the 5.5-inch prop, which I'm really excited about. A lot of stuff coming. This was supposed to be a frame build Now I have no more voice. I have talked too much. So that's the end of this. Please floss. Hope you enjoyed this. And sorry for talking so fast. And sorry for such a long video.